So it's the same test paper. Now we'll discuss the structure questions from this test. We discuss the MCQs. Figure 1.1 is a speed time graph. Describe the motion from 0.9 minutes. So from 0.9 minutes from this part to 2.9 minutes till this part. So it's a straight line. When it's a straight line for a speed time graph, so what we say it has a constant speed. From 2.9 to 3.5, so this region, so means it is because the speed is decreasing, so we can say deceleration, or we can also say constant deceleration. 3.5 to 4.5 in this region. So what will happen? The object is at rest, not moving, because the speed is 0 from 3.5 to 4.5. That's why it is stationary or not moving, you can say. In question 22, calculate the weight. So how to work out the weight of a, so weight is mass times the gravity. So mass is 120 and the gravity you have to take as 9.8 and you will get the answer in newtons. And when you're solving a question in physics, always write the formula. The balloon accelerates upward from a rest. So initially the balloon was not moving and then it has acceleration and 8 seconds. What is the final velocity? So we use a formula. Always write the formula first. Acceleration is the change in velocity divided by time. The acceleration of the balloon is 0.45. Final velocity we don't know. The initial velocity is 0 and time is 8 seconds. 8 is divided, other side it will be multiplied. So it will be 0.45 times 8. That will give us the final velocity. That will be in meter per second. So 0.45 multiplied by 8. That will be 3.6. So 3.6 meter per second. The next is the distance travel. So if we need the distance travel, we have the formula speed is distance divided by time. So distance is speed multiplied by time. But in this case, the speed is not constant. Like first the speed was 0 and now the speed is 3.6. So when the speed is changing, we substitute the average speed. So what will the average speed? So average speed will be 0 plus 3.6 divided by 2. Because two values are there, that's why we substitute an average speed. So remember, whenever the speed is changing, as in this question, the speed changes from 0 meter per second to 3.6 meter per second. So we take an average, we add them and divide it by 2 to take an average and then multiplied by the total time. So this will be 1.8 multiplied by 8. That will make about 14 meters. Is it clear?
Yes, sir.
Okay. In question 23, the oil has a density of 0.8 is poured gently onto a surface with a density, surface of water of density 1. So they don't make, describe and explain why, describe and explain the final position of the oil. So what will, because as you can see, the oil is having a density 0.8 as compared to that of water. So the oil will be there at the top and the water will be there at the bottom. And why? The explanation, because the density of oil is less than water. So the oil will be there at the top and the water will be there at the bottom. And reason is that because the density of water is greater than oil, or opposite you can also say. Irregular shaped solid has a mass, has a density of 2.7. Describe a method to measure the volume of irregular. This is an irregular object. So what we'll do, we'll take a measuring cylinder, fill it with a liquid, then we'll add irregular object and record the final volume. And we just take a difference of the two volume, V2 minus V1, that will give us the volume of object. The volume of object is 83 and the density is 2.7. We need the mass. So density, always write the formula first. Density is mass over volume. So density is 2.7. The mass we don't know. And the volume is 83. 83 is divided, other side will be multiplied. So 2.7 multiplied by 83, that will give us the mass of this, and that will be in gram. So it will be 220 grams. If the density is kilogram per meter cube, then the volume should be in meter cube. Then figure 2.1 represent different positions of the moon. So first, here we'll have, when we check the position of the moon, we'll have a new moon or full moon, you can also say. At this position, we'll have a crescent. Then we'll have the first quarter. Then waxing gibbous. Then we have a full moon is there. And then we have waning gibbous. Then we have the third quarter. Then we have a crescent again. And you can say here at this position, full moon, or not full moon, I mean new moon will be there. Full moon is at position G. So these are the position. So there's a quarter of the moon, so that is position A, and full moon is there at position G. Then state the approximate time for the moon to orbit the Earth, 1 month or 30 days, you can say. The average distance of the Earth to the Sun is 1.8. Calculate the average orbital speed. So if we need the orbital speed in orbital, V is equals to 2 pi r divided by t. So it will be actually 28 days, but it's a variation is there, 28, 29 days. But when we write as a 1 month or 30 days, the cycle. Actually, yes, it is vary from 27 to 29 days. But whenever you're writing the answer, you write as 1 month or 30 days. The radius, it will be 1.5 into 10 to the power 8 kilometer. But to move around the sun, it takes 365 days, but we have to convert into hours. The 365 days we multiply by 24, that will convert into hours. So when we simplify 1000, like 110,000 kilometer per hour, that will be the orbital speed. Then speed of a light in a vacuum is 3 exponent 8. Calculate. So we again use the formula, speed is distance over time. So time is distance divided by speed. The distance is given to us in the question, the distance between the sun and earth, 1.5 exponent 8. But that is in kilometer. We have to again like 1.5 into 10 to the power 8 kilometer. So we have, this is meter per second. So we have to again multiply by 1000 to convert the kilometer into meter. And then the speed of a light is 3 into 10 to the power 8. So when we simplify, the final answer will be 500 seconds, which is about 8.3 minutes it takes to reach us. Then this is a planning experiment question. Listen, additional apparatus, what we need to carry out. We have to plan an experiment to find the range of a ball depends on angle at which it is launched. Like if we change the angle, the range or the horizontal distance which it cover will also change. The additional apparatus, what we need a scale and we need a protector as well. And how we do this experiment, will measure the angle, initial angle, and we roll down the ball and we measure the, like repeat the experiment with different angles. Key variables to be kept constant, like what are the things we should control or keep constant? The position where we release the ball, the size of the ball, the mass of the ball, these are the factors which should be, or height of the channel above the ground should also be same. Angle should different, but the height should be same. Then table, because here we are investigating the angle. So angle is theta and the unit is degree, and the range, the distance is there, and the unit is centimeter. So don't forget to write these columns with the unit as well. So angle, the unit is degree, and the range, the unit is centimeter. So if we change this angle, how far it travels, that we are measuring. And wherever we mention, we should always do the experiment for 5 sets of result and repeat and take an average. These are the points we should always mention. Is it clear? These are the structure questions from the test, which was related to topic 1.1 to 1.4 and 6.1 to 6.2.